Cool. So, hi everyone, Benza here. I'm here to present this open source project that my team has been working on. And yeah, you can just read the title for yourself most likely. And I also give you like a real quick summary in case you would just like be guilted into staying for the entire presentation. Most of what I'm going to be talking about is, first of all, we all know that secure code is difficult to write. It's like a really difficult problem. There's lots of static analysis tools that try to find security issues in code. I'm personally, and also like my entire team is not really happy with the existing static analysis tools because they are either like too heavyweight, they are like too heavy, slow, or they get too noisy by just having too many false positives. Um, there's like this lightweight alternative of using grep for just like searching through code, searching text in a code base basically, but it's really difficult to use grep. It's basically impossible to use grep to really find smart pattern matches that actually correspond to issues that you're trying to find. And so what we felt like was that we needed something that like is an open source tool, like definitely has to be open source because why would you use any other kind of tool? It has to be fast. It has to be like more expressive than grep. Like it has to really understand the source code to be able to write queries that match exactly what you mean to match. And yeah, we just really wanted to write something that kind of follows a Unix philosophy that you can use as a standalone tool, probably connect it to other systems or anything like that without taking. I mean, like this is a personal anecdote. I use this static analysis tool, which is like a commercial tool. You need to like subscribe to a license. And when I wanted to run it in CI, what this tool actually did is it had like a central server where we configure all the different like static analysis rules, all the security issues that we want to find with it. And it would, on every single CI execution, compile a new Java binary with the source code, with like the code, with like the meshing code for detecting all sorts of different security issues. And that's just like really not how I roll. So I really don't want to keep using tools like this where they push down a new compiled binary for every single scan. That's nah. All right. And so like if you actually want to understand like what a tool like this can be used for, if you haven't seen a use for it before, though probably have, the four major things that we feel like it's useful for is, first of all, you can just like look at an existing code base or an existing organization and find security bugs in the code of this organization. Second, you can continuously scan code, so like continuously scan all the changes that come into an organization. So you're enforcing reliability practices or security best practices. Um, the third thing we are kind of experimenting with now, which is kind of like monitoring. It's kind of like keeping inventory of what's going on in your team. So across different repos, you could technically write like a code search pattern that just finds everything that is ever logged to standard output or like everything that's ever printed. So your security team can like check whatever gets logged. And like when something new is being logged to your log streams, the security team can like get a notification about this and verify that there's nothing sensitive being logged or something like this. And the last thing that is also kind of like an experimental feature right now is just like Semgrep can be used to not just find but also replace code, so it helps a lot with refactoring. All right, and now the least interesting slide in the entire presentation, where I say that, hi, I'm Benza, and so I work at this company, at this team called R2C. It's a San Francisco-based startup. I've only joined this January, so this entire time we've been on lockdown. If I managed to visit them in the US, like the team photo would probably look something like this, but that's just like a close approximation from me. Um, I also tried to be a digital nomad this year, so like travel around to different countries every couple of weeks, but I feel like I'm the absolute worst at being a digital nomad. Like immediate, like 1 month after I started, I got stuck with like border closures. I always leave everything at my previous apartments and like pretty much I think what I'm gonna present now is like the only good thing to come out of 2020, Semgrep, which is like a development from this year kind of. Um, let's just give you like a quick outline also, so you know what to expect. First, I'm going to tell you about how Semgrep came to be, but only in 60 seconds, so I don't bore everyone. Second, I really feel like I need to talk about trees, not because of my obsession with trees, which is non-existent, but because like we need to understand syntax trees to really understand what this talk is going to be about. Third, this is gonna be the most meaty part of the presentation. I'm gonna try to teach people how to use Semgrep to actually search through code and like do all of these things I've just described. And I'm just gonna show off some couple nice integrations that we've already built on top of Semgrep and like these kinds of like extensions where we are trying to build an ecosystem around this sort of security scanning tool. Also, anytime I really appreciate interruptions with questions. So like if anyone is wondering about anything, do unmute yourself and just tell me. All right, now the quick history part. This here is our GitHub repo. You can actually see that it's a really mature repo by now. Some people think it's because of the 2000 stars, but I think a much better sign of maturity is that you see like the first 5 items in the directory listing, and none of them are actually code. So that probably means that we already have enough process kind of like preventing us from just hacking on the project randomly. And I also need to give a quick shout out to Johan. So actually the reason I asked about Coccinelle before the presentation from you, Georges, is because Semgrep, the tool I'm about to present, is kind of just like an evolution of Coccinelle, which was a tool written by Johan, who used to work at Facebook for, like, he used to work on code analysis projects at Facebook. And so he is one of the main contributors to this tool that was developed for, well, kind of like searching through and replacing code in the Linux kernel. And then our team basically just like took over development. We hired Johan after he left Facebook, and we just kind of started developing it further this year. Yeah, so that's about the history. And like a real quick slide I need to show everyone, just so you know what to expect from Semgrep. So it is like an actual open source licensed project, LGPL, as you can see on the right. And the other thing that's probably going to matter to a lot of people is the language support. So you can search these, well, let's see, that looks like 10 languages to me. Yeah, these 10 languages, where a couple of them are in beta or alpha. Whenever a language is in beta or alpha, it usually means that we can correctly search through, let's say, like 95 to 99% of code written in that language, but we are still like expecting bug reports where like some things we just aren't able to parse. All right, so now this little part about trees that I promised. If you are tasked with this problem of wanting to develop some kind of tool that scans through a repository to make sure that nobody ever uses, let's say, MD5 hashing, because we know that MD5 hashing is like an insecure cryptographic algorithm. It should be banned from all of most organizations' projects, I guess. And so let's say you want to find that. Now, you might want to just like write a smart regex that tries to look for a call to MD5 functions. But you see the issue as illustrated by this XKCD. Well, it's not even like this, now I have 100 problems. It's more like now I have 100 false positives, because your idealistically written, utopistically written regex is going to assume that wherever MD5 shows up with like a parenthesis, for instance, it's an issue. Even though, let's say it might be in a commented out code block, or it might be just being printed out to logs saying something like, hey, we just hashed this person, but not with MD5, because we know that's not secure. Like even if somebody just like writes this innocent string to the log stream, your regex pattern would match that and would not know that that's not actually code that's executing. On the other end, there's also lots of false negatives where you might not realize if somebody is being devious enough or like misguided enough that they import the MD5 functions instead of MD5 saying it's like a hash function. So like if somebody just writes import MD5 as hash function and then later calls hash function, then your regex would have no way of knowing that what is a later called hash function is actually this blacklisted function. And the like root of this problem here is that grep is a tool for searching through text, but source code is just conceptually not text. So source code is not like a string of characters, and the string of characters that we see in the source code file is actually just kind of a human readable representation of what code really is, which is a tree. Like in this side-by-side comparison, it's actually the same source code. On the right, you see like the tree, which is how machines understand the source code and the instructions, where you have like these leaf nodes, let's say like a function definition, which has two parts below it, like the function name, let's say, and the function's code. And so all source code files are this binary tree, well, not binary, but like n child nodes tree with like this huge structure. And we just kind of translate that so that humans are easily able to read this tree. We translate it to text. But now if you want to like if you have questions about whether something is in this source code, going through this kind of translation layer of like tree to string and then searching on that is kind of like trying to read some, let's say, trying to read War and Peace after having Google translated it to Japanese and then Google translating the Japanese text back to English. It's just like kind of far from the conceptual truth of the original work. Okay, so now about this tree matching thing. So like if we agree that we cannot really search code as text and we want to search it as a tree instead, we already have some options for this. There are like actually quite a few static analysis tools that read the tree as opposed to reading text. So there's like GoSec for Golang, there's Bandit for Python, there's ESLint for JavaScript, and all of these are working great. The only issue with this is like if you want to like author customized rules, or even if you're like trying to just like create one of these tools yourself, it's insanely expensive in terms of work because you now need to learn the syntax tree of this language. You need to be an expert in like the syntax tree and how it's structured in a specific language, and then you need to be able to like have the abilities just to, let's say, write a checker that blacklists the MD5 function from our previous example. You now need to have the expertise to actually express this in like walking the tree, like parsing a source code tree, walking it, identifying when something is a function call in all the different ways possible for it. So it's lots of work. And actually on the right here, I don't expect you can actually read the code, but that's completely fine. I have an excerpt from GoSec, one of these open source Go static analysis tools that tries to find calls to old cryptographic calls. Well, not just tries, obviously it succeeds as well. But the issue is that it takes 100 lines of code just to find a couple different kinds of function calls. And that's really not feasible when, let's say, your team has a very specific requirement on how like your business logic needs to operate in a secure way. Now there's also, I want to give a passing mention to commercial analysis tools, which are kind of, you know, like you could just kind of pay someone to write this code for you by doing this and like trust that they will give you some sort of way to add your own checks to it or to like give you a nice registry of checks. But as I mentioned before, these tools, in my experience, are just incredibly slow. They are not very extensible, and they're obviously expensive. Like probably you want something free if it exists, and it's just as good as the commercial tools. And like just as like a last little side note on this like trees versus text thing, there's this code analysis blog post on the Instagram engineering blog that I like referring to, where they define this sort of spectrum of how there's like these easy but dumb code analysis tools, which are just like running a couple of regex based searches versus these whole program analysis things that like actually understand even like import statements and how all the different files chain together. which are really powerful, um, but obviously they get very complex and heavy and slow. So just to place Semgrep, the tool I'm presenting on the spectrum, it's like right in the middle, um, where it's like an abstract syntax tree based linter. So like it's less dumb than regex. It's also much more lightweight than these complex tools like MyPy, for instance, because we don't really understand, we don't actually follow any links between files. We only understand the syntax of one specific file in isolation. But anyway, we try to kind of like be right in the middle ground where it's not dumb, but it's also not too complex. And like the thesis of Semgrep then is that we want to let you do this kind of like tree matching by reasoning about the code analysis the same way you reason about the code itself. So like when you're trying to match something like eval request, the pattern, and this actually works if you tried it right now, the pattern you use to match eval request is just eval dot dot dot. All right, cool. Time for the demos, much more exciting. Um, just so you know what I'm going to be demoing, I'm starting with like a real quick overview of the basic functions, functionalities in Semgrep. I also have a couple examples of how it actually works in practice and like real life scenarios. And I also wanted to show off like a couple advanced features that I think are pretty cool, but you will probably not need them until a couple months into your use of Semgrep. All right, so here's the first simplest example. So what we have here is the same example I've been saying before as well, where you're just trying to deprecate a function or ban a function from being used, for instance, because it's an old crypto function, such as this RC2 function. This is an example in Golang. Of course, like if your language was on the previous slide with the 10 different languages, then whatever I'm showing you here is going to work exactly the same in any other language. And so what I'm going to be showing everything off on is this website called semgrep.dev. It's kind of like a live editor we made to make it easier to match different kinds of, like, basically it's like a rule authoring or pattern authoring tool. So what you see here, up here is the Semgrep pattern. So like this is kind of like where the regex would go if you were using a regex to match the code. And down here what you see is the source code snippet that we are trying to match. This is the same thing as here in the slide. And what I'm trying to do is match all occurrences of RC4 new cipher. But for instance, now I just selected this text, and again, you see like with this naive search for just the text, it tells me about this comment here and also tells me about the print statement. Like neither of those are actually issues. All right, so what happens if I just take this, what I'm trying to match here, and paste it in as my pattern? So the analysis ran, and it's already much better than just using a regex. I literally just copy pasted some piece of code and it's already matching a lot better than regex because you see we matched the basic case. We also matched this one where we had some like really weird devious spacing to try to trip up the tool. And we see that the comment was correctly understood as being a comment and the string was correctly understood as being a string as opposed to code. It's like we have these two matches right now, but we also want to match this thing where the key parameter is swapped to other key. And all we do here is actually just write dot 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 and use it as a wildcard to like be willing to match anything here. And so you see like in our match list here on the right, we have, yeah, right here, we have 3 matches listed, which does actually correspond to the 3 lines that we wanted to match. Ta-da, that's Semgrep. Well, okay, let's actually get a bit further into it, where it gets a bit more complex. All right, so what if we want to blacklist an entire library or like an entire standard library module, such as unsafe in Go? For anyone who's not familiar with Go development, by the way, I'm also not familiar with Go development, but I did read up on the specific slides and examples I was using. So there's this standard library module called unsafe, and as the name suggests, it is unsafe to use in terms of memory safety, actually. So like everything in this module is specifically written so that you can go around Golang's memory safety guarantees. So you probably don't want this in a production project. And so what we're doing instead is trying to find all of these uses, such as unsafe pointer, unsafe size of, and so on. Now, to go from where we started, if we just try to find any use of unsafe pointer, copy paste it over there, run the pattern, and we see that, yeah, we do have these two matches, but of course we didn't match unsafe size of. And so what I'm going to show here as a pretty cool feature is rather than using three dots, we also have what in regex shows up as capture groups. So I can write a dollar sign and just uppercase characters afterwards to not only match anything as a wildcard, but also hold on to the value that I'm matching. So now I can use this, for instance, for saying, yo, don't yet dare use func. And now this is the same variable that I've written above in my pattern right here. And when I run it, instead of saying match found, yo, don't you dare use pointer. And there we go. So now we have a working capture group. Another cool thing that capture groups can be useful for actually is not just for the message, but within the pattern itself. If I write something like x equals x, and I'll just switch this to Python, which is a bit easier to read, let's say. Now if I try to search x equals x, it will actually make sure that both of these x's in the result are the same. It's like when I write 5 equals 5, that matches, but when I write 5 equals 6, it does not. All right, that's meta variables. Um, how's everyone feeling so far? I'm uh, I'm probably not going to be interrupted because everyone's too scared. But if anyone has questions at this point, oh wow, I got a thumbs up. Wonderful. Cool. Let's move on to the next example. This is just like it's like a really simple example again. Partly I'll use this just to show that like we can do a lot more than obviously just like placing wildcards in variable names or whatever, or like in like parameters. So the one that we're trying to use, the issue that we're trying to match here is a broken configuration for TLS. This is kind of like an object or dictionary or mapping, whichever you're familiar with from languages that you're familiar with. And what we see here is the wrong SSL version being used. So this is like an old version of TLS. We don't use that. And we also have this other misconfiguration here where SSL verification is just skipped entirely. Now, the first part of this is matched by just, again, copy pasting this piece of code and adding wildcards on either side of the erroneous setting. So like it's like dot 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 min version SSL30 dot dot dot. These dot dot dots just eat like all of these other parameters that I just deleted. So we are able to match this. But another thing we can do here is add multiple different patterns to the same rule. So like here, this rule is just for, well, the message is not very useful. Let's just update it to that's some broken SSL right there. All right, and we're gonna add all the patterns that constitute broken SSL for us. Super easy here, because I'm just gonna copy paste the erroneous configuration from down here, which is insecure skip verify true. Now we have in this construct called pattern either, and we have a rule for finding any kind of, well, I mean like any implemented kind of broken SSL configuration. All right, let's jump to the more exciting stuff. It's just like building up, isn't it? We have a couple nice real life usages of Semgrep that I want to show off. First of all, I will assume that let's say around 20% of you are familiar with Golang, so I'll just explain this specific issue. In Golang, you can create kind of like background tasks or like asynchronously executing functions. And it is really unreliable or like it's kind of like really surprising to a Go developer when they call a function that's not marked asynchronous, but all it does is do something in the background. So essentially what we are trying to filter out here is when somebody creates a function where you have like an asynchronous execution that's marked with like the Go keyword. So like no function should have only an asynchronous execution in itself because that's confusing to people. All right. The way we are going to implement this check is something I'll need to open specifically because I didn't pre-open this page. No worries. So again, we are going to be composing two patterns, but this time we are not composing them by saying this or this. What we are saying is the code has to be something that can be an asynchronous function, so like a Go function, a Go routine, like this one. But we don't want to match if there's other things in this function as well, because like that's not so confusing. Like if you have any more lines of code, like you can see down here. For instance, this one, let's say, is normal because it does call something in the background, but it's like not the only thing it does. So it's probably justified. Now, the reason I'm showing this is because you can compose these patterns in more ways than just like this or operator. So like you can check like whether the first snippet is actually inside a larger snippet, for instance, like inside the function definition. And the one we are specifically using here is the is not, which means if I only ran this, it would find all sorts of like Go function definitions. But here, when I run it, now if there's any source code after the Go function, this not construct kind of removes that match from the list of matches. So we only get one match in total. All right. Let's just go back to this presentation. Yeah,
There's
there we
a
go.
quick question about if more languages are coming or how you would add more languages. And in
Yeah,
specific, it's Rust, Perl, and Julia that are of particular interests.
yeah, I do remember that we have a GitHub issue tracking Rust support. So right now, basically it's kind of like a popularity contest on our GitHub repository, which if you want to create an issue right now, you can find it at return to corp/semgrep. You can find it also through just going to semgrep.dev and clicking the GitHub link. So your best bet would be opening a GitHub issue where we have, let's say, like Fortran, an issue for Fortran and for Rust. And the work involved with introducing a new language is actually not insane because we found this kind of like collection of source code parsers called Tree Sitter. It's a project, I forget actually by whom. I think it's by GitHub maybe. And it kind of only takes a couple of weeks to be able to take this library's representation of a syntax tree and kind of convert that to what we are using internally in Semgrep. So upvote this thing there. I just gave you an upvote in case you're too lazy to do it yourself. And that's basically it. All right. Now that we have a break, I'm still happy to take questions from the chat, but I assume no other questions have come up. All right. Let's just lunge forward with this one. So I've been kind of talking about um, the need for customizability or like the need to write your own rules within your own project or team or company. And this is something that actually comes up pretty often. The example I'm bringing up here is kind of a contrived one. So the scenario here is supposed to be that you are making some sort of financial transactions, and the way the engineers of olden times have implemented the system is anytime before you make a transaction, you need to call a verify transaction function before, like verify if the transaction would be valid. Now, yes, that's kind of bad design, but let's just go with it for now and recall that like our rule is whenever you make a transaction, you need to call verify transaction on the transaction before. All right. And again, honestly, I don't feel like I need to really explain these patterns because they read really well. They're kind of self-explanatory. So we just say like, if there is a make transaction call anywhere in the code, then alert about that unless there's a verify transaction call before it. And so the sample code down here shows like a whole bunch of different issues here, such as here, somebody makes the transaction first and then verifies it. That's marked as an error. Um, Again, same thing here, or just not verified at all. And so you can see that in any case, Semgrep understands like the order of the function calls and all that, except one case actually. Um, this I just left like as an exercise to myself on the presentation to make it more of a live demo. But what's happening in this last function definition, let's see if I can zoom in. Yeah, there we go. Like what's happening here is somebody made the mistake of verifying the wrong transaction, not the one that they're making. And so currently the way our pattern is implemented, it doesn't really understand um, that like verified transaction needs to be called on the same transaction as we are making. But some of you might actually be able to already guess how we are fixing this. We are just going to add a capture group, like a meta variable, and we mark that these two have to be the same. So like now, if I run this rule again, ta-da, we actually have a match here. Like Semgrep now correctly understands that this was the wrong variable to verify, and this is the correct one. Okay, cool. That's basically all you need to know to just kind of start using Semgrep at your own on your own projects. Like that's honestly really enough for you to just like play around and write rules for yourself even if you feel like going above like the pre-written rules that we publish. But I will show like a couple advanced features just because they're cool. So there's this one about the route inventory. Um, what we're doing here is we have this internal experimental tool that searches for API routes defined in any of our repositories and just gives us a like unified interface where our security team can actually like have a look at all the API routes in our entire organization and some details about like whether there's authentication required for this endpoint, such as like here this yellow mark says that authentication is required. I guess it's green. I guess I'm colorblind. I don't know. This red mark means that authentication is optional, and so it's like a really nice view for our security, our infosec guys to like really just like have a nice inventory and like an overview of what's going on in our company and what they need to be worried about as the attack surface. And if you're wondering about how to match the API route, of course, it's like super simple, just like before. In this example, we have a Go API router, a Golang API router with like a bunch of different routes, like product, whatever, different methods and everything. And the pattern for that is, again, you just copy paste the source code and you replace whatever you want to make a wildcard with a meta variable. And so the cool thing about these variables is because they capture part of the code, now you're able to actually use the route, the methods, the authentication status, like the presence or absence of authentication, and so on, and like whatever you're using to process the JSON output from Semgrep. And that is what makes it possible for us to have this view of all of our API endpoints. Now, another cool thing that many people ask about is automatically fixing the issues that Semgrep finds. Going back to this previous example with the SSL configuration, rather than just complaining that SSL 30 is the wrong version to use, might as well make Semgrep fix the version itself. All you do here is when you're authoring a rule in this YAML syntax that you have for like more complex rules, and I might want to show off, by the way, like if you're on our semgrep.dev live editor, and we have like this simple web UI for just entering a pattern and like maybe clicking around to compose a few of them. But what's happening behind the scenes is the website is actually translating this into a YAML file. And so what Semgrep actually understands is these YAML files that define like a rule ID and a rule message usually, and also the pattern. All right, so here we are editing the YAML version, which defines a specific security scanning rule. And after having matched the wrong configuration here with the same pattern as before, now we also added this thing called fix regex, where Semgrep just looks through the match and does a simple text replacement on these issues. So that means that whenever I run Semgrep and I find this issue, other than the error message, I also get an auto-fix suggestion that I can just click apply on, and ta-da, code is green, fixed, everything is great. All right, so I think this one is the last advanced feature I want to show off, which is for like those kinds of rules that like need even more power, kind of, than SendGraph already provides. One thing you can do here is in that YAML file, you can actually write some Python code that will be executed. Obviously, this is like a very insecure thing to do. So like you need to be absolutely sure about what this Python code that is being executed is doing. Um, it requires a flag whenever you run a semgrep execution with Python code in it in the YAML file. You need to say dangerously allow arbitrary code execution from rules, just to like make it extra sure that you intended to run somebody else's code. But it is really powerful. So like within organizations, this is great. Um, the example right here is, well, let's ignore this example because there's a simpler one I can show off. Specifically about RSA cryptographic key generation, where common wisdom is that you want your RSA key to have at least like 2048 bits to have like a sufficiently strong key. So if you wanted to match this number in all RSA key generations, and you wanted to check if it is actually at least 2000, let's say, um, rather than writing out 1,000 different disallowed patterns of like, no, 1,000 is not allowed, no, 512 is not allowed. Easier way to write this is having a pattern where a meta variable catches the number of bits that you are using for key generation, and then writing this simple line of Python code. Like, this is an issue if the number of bits is below 2048. And we can also see this in action right here, where 1024 is marked as an issue, but 2048 is not. And I guess just to show that it works for everything, if I just update this to the probably not working, like probably broken 2047, we also get an issue. Alrighty. So that was actually like all of the Semgrep rule matching demos that I had. I do want to take like 3-4 minutes just to talk a bit about what we've already built around Semgrep. So obviously most people don't just want to search through their code once and be done with it. So we've been integrating Semgrep with continuous integration systems that are able to just like scan every single commit that comes into a repository to see whether it introduces any new security issues. Um, First of all, if you already have a system like this and you just want to integrate Semgrep, it's super easy to do because other than the human readable output, we also output like we can also output things in JSON format. Also, we already provide a Docker image, so you can like in most CI systems, you can just specify that you want to run this Docker image, and that's basically all you have to do. To really show off like what this means, like that's basically all you have to do. This is literally the entire GitLab CI configuration for scanning a Flask project with SimeGrab. You depend on line 5, you depend on the Docker image that we provide for this. And on line 7, you call this Semgrep agent script, which is like a small CI wrapper script with the config you want to run, such as like all the Flask rules. If you also want to see how this looks in reality, so this one is actually a screenshot from GitHub because Semgrep works in like basically any CI provider. And whenever someone opens a PR, this line of code will just give you output like this. Like, hey, I looked at this one new change that came in this PR. I see there's this new issue here about an open path traversal. All right. And the other thing, other than CI, that makes it like actually useful as a tool is that we have a rule registry. So we already have like, I think it's like more than, oh yeah, it's right here on the slide. We have 700 plus rules written for all kinds of different security issues, all sorts of different languages and frameworks. Um, like all of these rules are YAML files that you can find on GitHub. If you go to return to corp/semgrep rules, that's where we are committing all of these YAML files that we've written internally, or maybe that our community has contributed, because we actually have kind of a really cool community already. In the Node.js ecosystem, there's this static analysis tool called Node.js Scan. So the maintainer of Node.js Scan actually updated their code, and in their V4 release, their most recent release, they are using Semgrep behind the scenes to do the code scanning and like the code searching. So obviously we got all of those rules from Node.js Scan inside our registry now. Um, we've also been working with GoSec and FindSec bugs, which are these abstract syntax tree checker tools for Golang and Java respectively. So we've gone around and like looked at existing static analysis tools. We've kind of tried to port their rules to Semgrep rules just because it's like so easy, so much easier to express rules with the Semgrep language. So we have all those rules as well, and yeah, a bunch of other ones as well. 700 plus. And other than our registry, there's even like people such as Damian, who is kind of a famous person in the Golang community. So what Damian has done is he's actually created his own Semgrep rules repository, like his own personal registry basically. He already has like dozens of Semgrep rules that he's adding here at his Semgrep Go repository. You can check all of those out as well. Um, yeah, so as I just mentioned, you can like open the Semgrep website, semgrep.dev, and if you go to the registry explore page, all that does is it's like a web UI for the GitHub repository where we are committing all of our YAML files. And if you want to try one of these out, all you do is you either install Semgrep with brew or you install it with pip. Either of those works. You can just write pip install Semgrep as well, and you run Semgrep with one of these URLs that you found from the registry.